Hello, and welcome to the screencast for section 5.1 of Active Calculus about constructing the graph of an antiderivative. So first we want to start by talking about how can we get the values of antiderivatives algebraically. So we're going to start by having a function f of x that's defined to be sine of x, and big F is going to be an antiderivative of f, and we're told that we know f of pi over 2 equals a half. We usually call this an initial condition, or sometimes value, as a way that we can figure out, it'll enable us to figure out something because we have some value of the function big F. So now we're looking at what is big F of pi. Well, the Fundamental Theorem of Calculus tells us that big F of pi minus big F of pi over 2 is the integral from pi over 2 to pi of f of x dx, since big F is an antiderivative for little f. Well, here we actually know what little f is, and so we can put in sine x dx, and then use the fact that we know from chapter 4 that so the Fundamental Theorem of Calculus helps us now evaluate this by using any antiderivative, not necessarily big F, tells us that we now have minus cosine of x evaluated from pi over 2 to pi, which is then minus cosine of pi minus cosine of pi over 2, which is then minus 1, minus 0, so that's 1. And so now we can move this piece over to the other side, and we can say that f of pi equals 1 plus f of pi over 2, which then is 1 plus 1/2, since we're told that f of pi is 1/2 up here. And so we get that this is 3/2. We could also do, I'm going to do this a little bit differently. I'm going to say, okay, save that last algebra step. For f of 3 pi over 2, I'm going to use the fact that I could just bump this over to the other side and say, so rearranging what the Fundamental Theorem of Calculus tells us, that this has to be equal to the integral then from pi over 2 to 3 pi over 2 of sine x dx. And I'm going to use the fact that f of pi over 2 is a half. And now we have minus cosine of x is any old antiderivative, since that's what the FTC says we're allowed to use. And so then we get a half plus, I'm going to put the minus sign out here, cosine of 3 pi over 2 minus cosine of pi over 2. Oh, well, those things are both 0, so we just get a half. And finally, we can do f of pi over 4 in the exact same way. And that's f of pi over 2 plus integral from pi over 2 to pi over 4 sine x dx. Use the fact that f of pi over 2 is a half, and again, our favorite antiderivative here. Now this is a half, and then we've got plus minus cosine of pi over 4 minus cosine of pi over 2. And let's see, cosine of pi over 4 is root 2 over 2, and this piece is 0, so that whole thing is a half minus root 2 over 2. Now this, having written all of these in this way, leads us to realize that if I told you a different initial condition, if I said f of pi over 2 was 0, the only thing that would change is you would come in here, and this part would become, would become 0, or this part would become 0, and this value would just change by being smaller by a half. And this connects back to what we saw with the mean value theorem, that if two functions have the same derivative, then they differ by just a constant. And so here, if we have some other antiderivative, big G, for our function sine of x, just changing this value is all that's going to happen graphically, as the text talked about. It's just going to shift the graph up or down. Thanks for watching.